I want to thank everybody for taking some time to join us in another 15-minute Feature Friday. And this week we'll be looking at license plate recognition, more specifically the do's and don'ts, at least the things that we've seen in the field that can help optimize license plate recognition. So we'll start off with the basics, and that's going to be around camera placement. All the settings in the world on the server side or on the XProtect side are not going to help unless you've got good camera placement. So some of the don'ts, don't try and capture too many lanes or too much with a single camera. There are requirements, there are things that you need in order to have that license plate show up. So trying to do 4 or 5 or, a dozen lanes, you just might be asking too much of the camera and the software. So you really want to limit that range down. The next thing is be wary of the camera angle, whether it be too steep vertically or too much on an axis or askew horizontally. You want to be as flat to that license plate as possible. It's not always possible, but we do have ranges in terms of how to try and get as close as you can and not go beyond in order to try and get the best possible capture of that plate. And the last thing that I have seen personally come up a few times is be wary of what your target is. Not all vehicles have the license plates in the same spot, so don't forget that not all cars are going to have plates in the front. So you're absolutely going to miss any of these cars because there's no plate for the cameras to read. Now, some of the do's when we talk about camera placement, limit that target lane to, I would say, no more than 2 lanes. You can probably get away with 3. My personal preference is 1 camera per lane. It's not always cost effective, but in terms of high accuracy, that's the ideal way to go. But yeah, try to limit to maybe 2 lanes. When we talk about those angles, we're referring to the pan and tilt. You want to keep that less than 30 degrees from center. And when I say from center, I'm actually referring to the plate or the target itself as opposed to the lane of traffic. You want to be no more than 30 degrees off center from that plate. So your pan and tilt should be directly looking at that plate. To the right-hand side, you're actually seeing a survey I did a little while ago where we were able to move the camera quite a ways off the lane, but because this ramp was turning, we were able to get about a 20-degree off plate by mounting the camera quite a way into the other lane and still be able to capture those license plates as it turned that corner. And then referring to the placement of the license plates, again, try to aim for the back of the vehicle. Within Canada, I believe it's a law that all vehicles have both front and rear license plates. In the States, for example, there are about 19 states that do not require a front-mounted plate. So the back of the vehicle is always going to be the best target area in terms of capturing a plate. The next thing is I want to talk about, last thing about placement are speed bumps and other items in the physical area that can help you capture the plate with a little bit more accuracy. Speed bumps are ideal. The area after that speed bump creates a separation between the two. It also ensures that the vehicles are moving slower, so we get longer transit times. And by transit times, I'm referring to how long that plate itself that we're trying to recognize moves across the frame from left to right, top to bottom, whatever that may be. The longer the transit time, the more frames we're going to capture, the more information we have to do the analysis. So slower speeds create longer transit times. That speed bump allows you to create separation between vehicles, so you have a better chance of capturing each vehicle as it passes. Long driveways can also provide extremely long transit times, and you've got a much flatter plate in relation to the camera. The only caveat there is if those cars are bunched up too close to each other with no turns, you can start missing vehicles if the camera is not high enough or off to the side. But definitely along driveways or roads that are very straight will assist with this as well. But then also anything in the environment that is meant to control traffic. We're talking stop signs, speed bumps, traffic lights, even pedestrian crosswalks, for example. Hopefully most people tend to slow down for those. So those are good areas to suggest or recommend LPR capture cameras. And anywhere that there is a choke point or, reducing from multiple lanes to just a handful of lanes would be ideal. Now let's look at camera settings. These are going to be some of the settings that you can take advantage of inside the camera. Now, from camera manufacturer and even make and model, you are going to have not all the settings available to you. Some of them you might have a few more, but some of the ones to key in on are don't rely on any automatic settings. So things referring to auto gain, auto exposure, auto compression. These are all things that are going to generate noise into the image, and it's just going to make it harder for LPR to recognize the plates, distinguish what is a character versus what is background noise. So you definitely want to try to avoid using these items or these settings in your system. You definitely want to go in and manual settings optimized per camera is the ideal way to go. Even two cameras around the same building that are facing slightly different ways are going to have their own environmental issues to deal with. So you definitely want to recommend manual settings and go through those settings to optimize it for plate recognition, not so much best picture in terms of the human eye. Another item here is contrast. This is going to come up quite a bit. Low contrast means less detection between different gradients. So higher contrast, you're shallowing out those gradients. You're getting better edges on the characters on the license plate. So you can go all the way up into high contrast, but you definitely want to avoid using either an auto contrast or a low contrast setting inside the camera. Okay. And one thing to remember, this comes up quite a bit, frames per second is not equal to shutter speed. You have a lot of cameras will have the ability to fix a shutter speed on their video. This can be from, as we see here, 1/30th of a second, 1/500th of a second, or even more. This is going to not be related to frames per second. A lot of people think if I just boost the frames per second, 30, 40 frames per second, I should get crisp reads. That's not always the case. Higher shutter speed will give you sharper images despite the frames per second. So these two things are not synonymous. Let's talk about a few camera features. Again, not available in all cameras, but things that have been made available that can help license plate recognition. One of them is either a high dynamic range or wide dynamic range. I say that with a grain of salt. At night, wide dynamic range can induce noise. So a lot of cameras have features like highlight or headlight compensation. That's what the image here is showing. And it takes those very bright lights, especially in a darker environment, and just kind of moots them out a little bit. And you can see here that at least the license plate is visible when HLC is turned on. So that's going to be based on the camera. HDR or WDR is going to give you at least a little bit of an edge when lighting is a little bit of an issue. But when possible, headlight or highlight compensation is also going to give you that edge as well, especially in the night. Okay. Some cameras will have an auto iris. This is the preferred exposure control because the auto iris is controlling the light, at least to the best of its ability, but it's doing it optically. So it's not going to add anything to the video itself. It's not going to modify the recording in terms of noise or gain or anything to artificially increase or decrease light. This is simply using the iris on the camera to open and close to control that light to try and balance out the exposure. This would be that only possible exception to the rule of auto exposure is an auto iris, but again, it's one of those things where you look at each camera individually to see whether or not this feature either helps or hinders reading the plates. Okay, and a lot of cameras now are going to have a feature, a night mode or just a black and white mode. These increase that contrast by essentially reducing out the gradients in a lot of the colors, and you're dealing with essentially black and white. And when you look at a plate, the dark blue or the darker colors are going to come across as black or near black. So you are getting that higher contrast. That's just a little bit of a boost in order to get a better read on the plates as they pass. All right, the next thing I want to talk about are IR illuminators. So these are items that a lot of the times IR lights are built into a lot of cameras. They can be added on as a separate piece, powered up with the camera itself. And these just send out an IR light that's invisible pretty much to the human eye, but license plates are very reflective to IR, and they will increase that contrast dramatically, as you can see in these images here. The left is daylight, the right is at night. Most plates in North America are highly reflective to IR, and the letters are not. So they will glow, increasing the read rates even higher. All right, so there is a sweet spot when it comes to IR. 590 to 850 nanometer wavelengths are ideal for license plates. These are numbers that you probably don't have to remember, but just know that there is that IR sweet spot in terms of reading plates. And with that being said, there are at least two examples that I'm familiar with here, where I am right now in Massachusetts, as well as the province of Saskatchewan. Those plates are not as reflective as most plates in North America, so it requires at least an 850 nanometer wavelength for IR in order for that reflectiveness to work. All right, let's jump into some camera configuration inside of XProtect itself. One of the key ones that you will see everywhere is use MJPEG codec. Main reason for this, as most of us are familiar with, the 264, 265 codecs use keyframes, so we're only getting one full frame, typically one full frame a second, regardless of frame rate, whereas MJPEG, every frame is a full frame image, and typically the LPR analyzer can only work with the full frame. So regardless of what you set your frames per second to, if you're using an H.264 or 265 codec, you're still only reading at one frame per second. When you use MJPEG, you set your frame rate to relatively low just because of the amount of bandwidth this is going to generate. But each frame you choose, whether it be 5, 4 frames per second, each one of those frames is going to be something readable that can be passed into the LPR service. So MJPEG is the ideal codec for LPR. And again, as I mentioned, because of that, typically a lower frame rate is all that's required, around 4 frames per second. And that's going to be heavily based on your resolution and bandwidth availability as well. But this allows you to get into that lower frame rates and still have functional LPR. All right. One of the things kind of touched on a little bit earlier is set the quality to fine or the compression to as low as possible. None would be preferred. Compression, especially JPEG compression, will add artifacts or noise to the plate itself. And as I mentioned, adding noise, adding those artifacts, they just start to blur that edge contrast between letters and background noise. So the least amount of compression possible when configuring the camera for LPR. And one option here is don't use all the pixels. You do not need an 8 meg camera or a 5 meg camera in order to benefit from LPR. There is kind of a formula that we use in order to figure out what the optimal resolution, or at least your minimum resolution is. So in the guides, it will talk about stroke thickness. I find it a little bit easier to just talk about the size of the plate itself. So for slow-moving vehicles, you're around that 130 pixels in terms of width. The faster-moving vehicles increase up to 215 pixels. Of course, if you can get more, it's better, but you're asking the system to do a little bit more processing. So dial it back. 130 to 215 pixels in terms of the width of the license plate is kind of that ideal area. And we know that the plates are roughly 12 inches wide. So with this information, you can do kind of a back of the napkin or back of the envelope calculation to figure out what that optimal, or at least minimum resolution for the camera is. So we'll do it really quickly here. Plates at 12 inches wide, I want to get 150 pixels per plate. I've got my camera mounted here to the right, and I'm only going to target this one lane for this process. So we measure that lane width, and my target area works out to being about 12 feet. So it's 150 pixels per plate at 12 foot of a target range. Gives me 1800 pixels, so I know that an HD 1080 will give me enough horizontal pixels to capture that range, and I know whether it's day or night, I've got at least enough resolution in order to get accurate reads, or at least relatively accurate reads, and I've got a little bit to play with, and I can cut some of that out if I needed to. When you're configuring that LPR camera, it is a good idea to take snapshots, a lot of snapshots. Typically, 300 or 400, maybe a little bit of extreme, but you want at least 5 to 10, if not more. And you want a variety of different weather conditions, day and night, positions in the lane, different vehicles, something so that you can really dial in on where those license plates are going to be read from. And so you can see there's quite an example, and you can do this ongoing. So you can always add snapshots later and refine those cameras. It's not a one-time setup out of the box and you're good to go. So this is what I was just mentioning, refining that recognition. Within the system, you want to really define that area, and you will get a configuration that shows what the recognition area is. So everything in red is not part of the recognition. Everything else is where it's looking for plates. And you want to try and really define that recognition so that you're narrowing in on just the area that you need to. And that allows you to basically ignore everything else in the view. So again, we're getting rid of all the irrelevant moving objects, anything that could cause problems or interfere with the reads. Okay. And one of the last things I want to mention, remember, we are not the only ones doing LPR. We've got a series of partners that are available to where we can look at the solution, look at the requirements, and see whether or not the Milestone LPR works for the project, or any one of our other partners that are doing it differently, doing it another way, or might be more in line with the requirements. So these partners are available as an option as well. And that brings me to the end of that slideshow. Are there any questions, comments, concerns, complaints? All right, I will take that stunning silence as there are no questions, or I've managed to put about 70 people to sleep. Regardless of that, I want to thank everybody for the time, and hopefully if there are any upcoming LPR projects, you can reach out to the pre-sales team, or we can get you any other information that you may be required. Have a great day.